We present Tandem, a system that implements two-sided CNC milling of objects like this quadcopter propeller. Two-sided milling is complicated and error-prone. Tandem solves this by implementing all parts of the process, physical and digital, as a single computational notebook program. The notebook communicates with conventional CAD and CAM software to generate machine tool paths as specified in notebook code. To account for physical contingencies, the notebook uses an augmented reality overlay which guides the fabricator in adjusting the physical setup to match digital preconditions in every step of the workflow. Once fabricators meet all the preconditions for milling a given step, they can dispatch jobs to the mill directly from the notebook. All parts of the notebook are generated by JavaScript code cells, and we developed an API to communicate with external tools from the notebook. We now walk through the workflow from start to finish. First, the notebook communicates with CAD software to automatically generate additional material around the propeller called the outer. A fabricator makes manual adjustments to align the tabs that connect the propeller to the outer. Next, with the help of the AR overlay, the fabricator synchronizes the physical location of the workpiece for an alignment jig with the location in the notebook. They then check a box indicating alignment, which causes that cell to now evaluate to true. They then change the AR overlay, which guides them in fixturing the workpiece with screws. The notebook then helps them set the physical origin, or 0, of the machine's X and Y axes and hardware, here positioned on the workpiece's center. They then send the measured dimensions of the workpiece to CAD. Tandem generates a cam setup for 2 holes in the jig into which the fabricator will press fit dowels. They briefly adjust the cam setup to mill 2 holes instead of 4. Tandem then generates machine instructions to run the milling job, but not all the preconditions have been satisfied. In this case, the hardware 0 is not fully aligned with the 0 in CAM. To solve this, the fabricator simply adds notebook code that zeroes the z-axis on the machine. They then dispatch the job directly from the notebook. Now that the alignment jig is done, the next step is to prepare the main workpiece from which the propeller itself will be milled. First, the notebook prompts the fabricator to switch the tool to a surfacing bit. This will help quickly remove excess wood from the main workpiece. They then go through the same process of aligning the workpiece and transferring measured dimensions to CAD and CAM software. One critical step is calculating the minimum depth of the screws so that they don't collide with the bit. The AR overlay guides the fabricator in counterboring and verifying safe depth of the screws. After generating the setup for reducing excess height, the notebook compiles the instructions to a toolpath visualization and projects it onto the stock. The fabricator notices that it's a bit tight on some of the edges, so they go back to CAM and add an offset over the edges of the workpiece and regenerate the toolpath in the notebook. After dispatching this job from the notebook and letting the mill do its work, the main workpiece is now the exact height of the propeller. The next step involves milling alignment holes in the main workpiece, similar to as was done with the alignment jig. After milling these holes, the fabricator can fixture the workpiece securely on the jig and be sure that they'll have the same position after flipping the workpiece later on. Tandem then generates a roughing and finishing cut for each side of the main workpiece, 4 cuts in total. Once the roughing cut is done, the notebook prompts the fabricator to install a ball end mill as the current tool. They then flip the workpiece. Normally, this step is where many errors reveal themselves, but because the fabricator has followed steps in the notebook and checked their work against preconditions, they can be confident that the second set of cuts will result in a proper artifact. Just a bit of sanding, and the propeller will be good to go.